This video serves as a review for fraction operations for addition and subtraction, and in particular we're going to focus on the idea when the denominators are not the same and we have to find the least common denominators. And when we want to find the least common denominator, that means we want to find a multiple of both denominators that's as small as possible. The idea of using the least common denominator is so that we can work with as small of a number as possible, but can still combine the fractions through addition and subtraction. So in part A, we have the two denominators being 15 and 10, and we want to just go ahead and find what's the smallest number that they share in common as a multiple. And there are a few different ways you can use in order to find the least common denominator, and I'm just going to introduce a couple here in this video because you might have some method that you already use, and these are just suggested methods that might be helpful for you to go over, and especially if you're less fluent in finding the least common denominator, this is going to come in handy. So the first way to find a common multiple, as we know it's a multiple, we can just go ahead and list out the multiples of the denominator. The first denominator is 15, so the smallest multiple of 15 would be itself. The smallest multiple of any number would be just itself, because that number times 1 gives it 15. And then we can go to the next multiple. 15 times 2 will be 30. 15 times 3 will be 45. And you can just list a few or a handful of multiples over here. And then for the next denominator, it's 10. So 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30 over here. And you could keep listing, but if you notice, we do have a common multiple between the two denominators already. That's 30. And based on this fact, I know that I want to get the denominator to be 30 for both fractions over here. And if we look back to the list of multiples, we got 30 on the second multiple of 15. So that tells me in order to get 30, I need to multiply 15 by 2. And whatever I do on the bottom, I have to do it to the top. So 2 times 2 on top, which gives me 4. Similarly, if we look at the list for multiples of 10, we have the third number being 30. That tells me 10 times 3 is 30, so whatever I do to the bottom, I have to do it to the top. And I have 9 times 3, which is 27. And now if I combine it, we just want to keep the denominator and add up the numerators over here. And it's important to remember the idea of having a common denominator is we're going to keep that common denominator. We're not doing any operation with the denominator anymore once we get the same one. And we're only operating with the numerator. 4 plus 27 gives us 31 over 30, and that's going to be the final answer. Now if we look at part B, we have 3/8 plus 5 over 12, and you can use the same method to find the least common multiple of 8 and 12, but I want to introduce a slightly different method. For 8 and 12, and any time you have common factors or least common multiples you want to find, you can always use this method, which is through the prime factorization. And if you think about how we can factor 8, you can even use a factor tree if the numbers get larger. So 8 is 2 times 4, and 4 is 2 times 2. So we can't go any further than 2, because 2 is a prime number. We can't break it apart anymore. So that tells me 8 is equal to 2 times 2 times 2, which is equal to 2 cubed. And similarly, if I look at 12, I can break this apart to 3 times 4. 4 again becomes 2 times 2. So that tells me this is equal to 3 to the first degree times 2 to the second degree. And to find the least common multiple, the goal is really for us to look for what are the factors involved and what's in particular the highest degree of that factor involved in each factorization. So as a result, if we look at the factorization, we have a factor of 3, and the highest degree of 3 ever showing up in 8 and 12 is going to be 3 to the first degree, because 8 doesn't have a factor of 3. We don't have to worry about it, but 12 contains a factor of 3, so we have 3 to the first degree. And now we also have a factor of 2, but in particular, the highest degree of base 2 is 2 cubed, coming from that factor, that denominator equal to 8. And when we include these together, these are all factors, so we're going to multiply them together. And whenever I calculate this product, it's guaranteed to be a multiple of both denominators. And in particular, it's as small of a multiple as possible. Because if we look at the factor 3, that's incorporated. So we know that the result of a factor 3 is considered. And also we have that 2 cubed. Compare that power of 2 cubed, creating a factor of 8, which means it must be a multiple of 8. And then 2 cubed times 3 is going to be a multiple of 2 squared times 3, because we have an extra factor of 2. And this is essentially how we go over this process and think about what's going to be the least common denominator. So we go through the prime factorization individually, and we look at what are the bases for the prime factors. We have a base 2 and base 3, and we write out each base. The highest degree of base 3 is 1, so we just write it to be 3 to the first degree, and highest basis for 2 is going to be 3, so we have 2 to the third power being the factor. And here, if we calculate it, 3 times 8 is 24. And that tells me 24 is going to be the least common denominator that we would have in this. And once we realize that, then we can basically rewrite this entire operation. We have 3 over 8 plus 5 over 12 to start. And I want the denominator to be 24. So 8 times 3 is 24. Whatever I do to the bottom, I have to do it to the top. So that tells me I would have 24 in the denominator and 9 on the top. And similarly, if I have 12 and 5, if I want denominator to be 24, to go from 12 to 24, I multiply by 2. So I should do the same on top. And I would get 10 over 24. And altogether, I would get 19 over 24 as a result. Now moving on to part C. In part C, this is actually a nicer scenario in a way, because we can see if we look at the denominator, 9 is a factor of 27. When that happens, that just tells me I don't need to do operation with both fractions. I only need to change one of the fractions. In this case, I said 9 times 3 is 27, so I need to multiply 3 on the bottom and top for the first fraction. But I don't need to do anything with the second fraction anymore, because it already has a denominator of 27. So the first fraction really is equivalent to 27 on the bottom and 15 on top, minus 1 over 27, which is 14 over 27 as a result. Lastly, for part D, we have the scenario of minus a negative value, so you could go ahead and change that minus negative to be a plus over here, and that's 5 over 18. And for the same argument as what we did in C, 18 is a factor of 36, so we can just multiply 18 by 2 to get 36. Whatever we do to the bottom, we have to do it to the top. So that becomes 5 over 36 plus 10 over 36, which is 15 over 36. And once you do so, this is somewhere you want to be extra careful. We didn't have to do it with any of the results, but in this one, we want to be careful looking at 15 and 36. They do actually share a common factor, because 15 is a multiple of 3, 36 is also a multiple of 3. So we're going to go ahead and divide 3 on both sides. And once we have that, we have 5 over 12 as a result. So this is a fully reduced solution, and that's what we want to have for the final answer.